Coming up on ScienceWorks, we visit a real TV studio to see what meteorologists use to forecast the future. But first, have you ever seen a giant cruise ship up close? Well, we're going aboard the Carnival Breeze to see what happens behind the scenes to organize and move a mini city across the ocean every day.
Going on a cruise is one of the coolest vacations. Eating, swimming, relaxing, exploring different islands and countries, all from a giant floating resort. But a lot of work goes into keeping thousands of passengers happy over a 7-day trip. Staff and crew rely a lot on what they learned in science and math class to ensure smooth sailing for everyone. We're standing here on the bridge, which is the control center of the entire ship. This is Captain Massimo Marino, and he's in charge of it all. Tell us, what is the bridge?
The bridge is the place where we are controlling the ship. We are controlling the ship in the navigation, so direction, speed, and course.
There's a lot of technology here, and you're in charge of it. What's one of the coolest parts about being in charge of this?
The most important thing for a sailor is to know where we are. So to know where the position is. To give us the accurate position today is the satellite, the GPS.
When I need to go somewhere, I just type it in on my phone GPS. Is that how you do it here?
Our GPS is more complicated, but it gives us an accurate position even in the middle of the ocean.
The GPS on the bridge is so accurate that even when the ship is in the middle of the ocean, surrounded by nothing but deep water for miles and miles, it gives a precise position within 25 feet. The bridge also monitors and controls stability of the ship, using technology to alter the center of gravity.
As the ship burns fuel and passengers drain water tanks, the ship will get off balance. The bridge controls ballast tanks to keep the ship level. All of this technology happens behind the scenes so passengers can relax and have fun. What's the coolest part about working up here in the bridge?
To be in control of this huge machine. It's a very huge machine. You have a lot of power. And controlling this machine is you feel
You feel powerful?
You feel important.
Does it feel nice to be sitting in that seat like...
You want to try?
Yeah, I do. I have the con! I'm here with Rick Miller, Vice President of Nautical and Safety Operations. Rick, let's talk about fuel. How much fuel can this ship hold?
We can hold roughly 1 million gallons of fuel.
So a car has how many gallons?
Oh, roughly 20 gallons, so we're talking about filling up like 50,000 cars.
On 1 gallon of gas, cars can drive an average of around 20 miles. Giant cruise ships burn 1 gallon of fuel in traveling roughly just 60 feet. That's only about the length of the gas station itself. But remember, the ship is moving 5,000 people at one time. So if 5,000 cars were driving at the same moment, they would burn up to 3 times the amount of fuel as one cruise ship.
So to figure out how much fuel is needed for a week-long cruise, first you multiply the distance you're scheduled to travel, let's say 2,500 nautical miles, by the rate of fuel consumption, 88 gallons per mile. This equals 220,000 gallons of fuel needed for a week at sea. We're on a huge ship and there's just water all around us. Do you use the ocean water?
Absolutely, and we have over 5,000 people that we have to take care of every day. So we have systems on board that evaporate the seawater and turn it into fresh water. We use a system called reverse osmosis also. A combination of that, we can make over 700,000 gallons of water a day, and we can store up to almost 2 million gallons of water.
So what you're saying is you take seawater that has salt, you put it through this process called reverse osmosis, and then it turns into water that you can just drink?
Right, it becomes fresh potable water, which we can use for cooking, for bathing, for drinking, and we can support all 5,000 plus people on board. We probably consume on average about 300,000 gallons a day, but we can make 700 and we can store up to 2 million.
That's a lot of water.
It's a lot of water. It's like 100 swimming pools in our storage tanks.
And is it safe for people to drink?
Perfectly safe. Let's go get a glass.
Still ahead, food, food, food. Meals are a huge part of a cruise vacation. We'll see what it takes to prepare thousands of delicious meals every day, while satisfying appetites for all ages. And later, back on dry land, we head into a TV studio to see what goes into accurately predicting the weather.
This is Fabian Gervais, chief engineer of this whole ship. So tell us what we're seeing. This is the control room?
This is the engine control room. Basically, it's the brain of the ship where we can control all the engine machineries.
What are the different parts that we're seeing of the engine room?
As you can see from that screen, the propulsion with the shaft and the propellers. We have the navigation system, bunkering system for the fuel oil. We have the power net there, and the steam generation, because we have 2 boilers and we have to produce some steam as for the galley and for the laundry.
So this is the room that controls the engines, but can we go down to the engine room and go check it all out?
Yes, of course.
The engine rooms are in the lower part of the ship, situated below the ocean water level. There are 2 propellers at the stern to drive the ship. Each have 6 blades that are about 19 feet long.
It's so loud in here. And look at how big these engines are. This is the room that powers the whole ship.
One of the 6, because this is DG number 1. We have other 5 units.
You have 5 more
5
of
of
these?
them.
6 engines are required because it takes about 60,000 horsepower just to turn the propellers with enough thrust to move the massive ship. In addition, the engines also need to generate electricity for all other services: lights, cooking, air conditioning, and so on. There are 72 megawatts generated on this ship, enough to supply 12,000 houses with power.
What else are we seeing around here?
This is the forward engine room, and you have 3 units here, and 3 other in the aft engine room.
And how much horsepower do they have?
We have 100,000 horsepower generated by diesel generators.
100,000 horsepower?
100,000 horsepower.
60,000 horsepower for the propellers, and 40,000 to power everything else on board. That's the equivalent to the power of 300 school buses to run this ship.
This is a high-tech ship, so there's a lot of high-tech jobs. We have just about every kind of mechanic and technician you can think of that does every specialty from piping systems, hydraulic systems, engine maintenance, everything in the engine department to basically run a small city afloat at sea that moves on its own.
It is a floated city. You basically have to be self-contained and have someone that can help in any situation.
Yeah, absolutely. And also, when you think about navigating, maneuvering the ship, lots of math and science involved in how we calculate the course, adjust the speed, worry about the trim and the stability of the ship to keep it stable and floating upright and going through the water. And you also have other disciplines. We deal with satellite communications, internet technologies. We run our own internet systems and communication systems on board. So it really is a city at sea.
I was wondering about that because I was like, how do I get cell phone reception if I'm at sea? But you can get it?
Yes, we can.
Okay, cool.
We run our own cellular network at sea, and it goes out through a satellite, and we can, on board, you can connect on your phone, your mobile, your laptop, just like you're at home.
A lot of work goes into making guests feel more at home. And keeping guests fed, comfortable, and having fun definitely requires planning and organization.
I'm here with Demir Mirsik, Carnival Breeze's hotel director. Now, you're in charge of a lot of people. How many people are you in charge of?
1,200.
And how many departments are there?
We have more than 20 departments.
There's food, beverage, entertainment, culinary arts, housekeeping, gift shops, and spa, just to name a few. There are 1,845 rooms that need to be cleaned in just 5 hours, which is the time they're docked between voyages.
It's obviously important to know how much staff needs to be hired for housekeeping in order to depart on time. Figuring it takes about 20 minutes for 2 housekeeping personnel to clean 1 room, multiplying the number of rooms, times the number of minutes needed to clean a room, times the number of people cleaning, and dividing by the number of minutes before the ship sets sail gives us 246 people needed to clean the rooms. I'd love to have a job where I can explore the world on a cruise ship. What are some of the positions here that use math and science?
I would say IT officer that is taking care of the internet on board, accounting department, food operation manager who orders the food for whole ship. And casino is just in charge of all the money on board. And there are so many other departments that they use math and science.
How does math and science play into your role as hotel director?
So it's a big part of my job because we need to know the usages, the timings, the guest counts, and we plan accordingly.
We see a lot of stuff happening on the ship. What happens behind the scenes?
We have a laundry operations actually that they are 24/7. It's part of the housekeeping. Also, we have a kitchen. We prepare 15,000 meals a day.
Let's go check it out. The galley is where the food is prepared, and this looks like the appetizers. Tell us, what's going on here?
This is a food preparation area for tonight's dinner. Our food orders are calculated based on the historic data from the past cruises.
The chefs utilize the large amounts of historic meal data and compare factors such as guest counts and travel itinerary to determine menus and the proper quantity and scheduling for serving food. They also factor in the varying ages of guests, as kids usually like different meals than adults.
So if you do have kids on board, what kind of foods do you increase and what do you decrease?
Majority is macaroni and cheese, hamburgers and hot dogs and pizzas.
The galley provides 15,000 meals per day, which is about the same as what 120 different restaurants would serve in a city. And variety is key. Many different kinds of food are available so guests can try new meals every day.
I love eating, and sushi's my favorite food, and that's what I would get, but what's the most popular dish you have here on board?
It's a lobster.
Oh yeah,
Yes.
that would be so good.
95% of our guests, they will try the lobster on the first Cruise Elegant night.
I'd like to thank Captain Marino as well as the rest of the Carnival Breeze staff and crew for showing us how math and science are used in keeping this floating city running with thousands of passengers. It's been fun learning about the mechanics of the ship as well as the process behind keeping people fed, safe, and entertained. I've really worked up an appetite. Let's go get some ice cream. Full steam ahead!
Up next, we're inside a TV studio to see how meteorologists forecast the future.
Being a TV meteorologist is really exciting, especially when you get to report on a snowstorm that may cancel school in the morning. Plus, you get to have fun with the green screen. But this is the fun part. There's a lot of work that goes behind telling the weather. Let's see how it's done.
Good morning, New Hampshire. Pretty changeable start to the day out there for us. Pretty thick fog in southern areas of the state, giving way to some sunshine and what should be a really nice afternoon. Temperatures mid-70s.
I'm here with Kevin Skarupa of WMUR. He's a meteorologist. Kevin, why did you want to be a meteorologist?
All goes back to the snowstorm when I was a kid, snow up over my head when I walked outside, and I was out of school for 4 consecutive days. Obviously, at that point, I had to figure out why that happened and how we could make it happen again next year, because it was wonderful. I got to play in snow for 4 straight days.
How do you tell what the weather is going to be?
When I tell people that I get here 3 hours before our morning show starts, they're like, what in the world are you doing for 3 hours
3
out ahead?
hours?
But we look at 200 different weather maps, which are done through a combination of surface observations across the country, weather balloons that go up every 12 hours, all jammed into some supercomputers, and then they spit out what will possibly be the forecast. And there are 9 different sets of them from all over the world.
Can you teach me what to do right now?
Sure.
I mean, I don't even know how to get out of the way.
Right.
It's backwards.
This weather wall, you know, it kind of transports everything back to this wall. And that's first person's inclination is to reach back at the wall. But when you do that, as you'll notice with the camera, your arm almost disappears.
Yeah.
So what you want to do is you want to reach outward. And so we use the monitors off to either side to be able to look at where we're standing
Yeah, I see
as
them.
to the maps behind us, and that's how we can know what we're pointing at.
Hey everyone, welcome to the weather. You can see over here there's some cloud coverage in Maine, in Canada. There is some rain. And then you've got a little rain here. Rain, 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 rain. And here, sunny, super sunny. Go to the beach, guys. Go to the beach. These are a lot of computers. Why do you have so many computers at this desk?
Each of them function differently. This first one makes the maps that you see on television, so I can go into any of these maps and plug in weather conditions. So you can see here that we can put any different weather symbols on this map, from thunderstorms to tornadoes to freezing rain.
There's a tornado.
There's the tornado.
All these computers help meteorologists like Kevin use complicated math algorithms to predict the weather and then present forecasts for a TV audience.
To you, it's going to look like a bunch of numbers on a screen.
Yeah, that's all it looks like to me.
In school, this is the 4 or 5 years of learning, is trying to figure out what all of these mean, from temperature to dew point to cloud cover, wind direction, wind speed. We used the math equations back in school so that we could realize what the strengths and weaknesses of these maps are, and realize that we just can't blindly say high of 87.
Coming up, forecasting the weather doesn't just happen on television. We'll see how the National Weather Service is on alert for storms and other potentially dangerous weather.
If you have an idea you'd like to see featured on ScienceWorks, visit ScienceWorksTV.com. Let us know what you think of this episode and suggest an exciting career or concept for a new show. That's ScienceWorksTV.com.
I'm here at the National Weather Service in Gray, Maine with John Jensenius. You're a meteorologist.
I am a meteorologist, yes.
I just met a meteorologist who was in the TV station. What do you do out here?
Well, there are a lot of things that we do. More than anything, we forecast the weather, and if necessary, we issue warnings to alert people to any potential dangerous weather.
Wow, so thunderstorms and that type of thing you talk about?
Yeah, we keep an eye on thunderstorms. We use our Doppler radar to watch where the thunderstorms are and to determine how severe they might be getting.
When I was little, I was told that when I see a lightning flash, I can count the seconds until I hear the thunder boom, and the storm would be a mile away for each second I counted. But the storm is actually closer than that.
The sound of thunder travels a mile in about 5 seconds. So simply count between the lightning and the thunder, divide by 5, and that tells you about how many miles away it was.
And how often does lightning happen around the world? Like at this moment, is there lightning happening?
If we think of just the United States, in a typical year we get between 20 and 25 million cloud-to-ground lightning strikes.
What are the chances that I get struck by lightning?
Well, that depends on your behavior. If you're very safe around thunderstorms, the chances are very low. If you're not careful, if you're outside and you don't plan ahead so you can get inside, then your chances go up. But on average, in any particular year, any one person has about a 1 in a million chance of getting struck by lightning.
Clouds are so beautiful and they look so light and fluffy in the air. How much would a cloud weigh?
Well, if we take a typical cumulus cloud, probably about 1.1 million pounds in terms of the water droplets.
So the white that I see in the clouds weighs over 1 million pounds? How come it doesn't just fall down on us?
Well, the reason is because it's in air, and the air that those little tiny water droplets are in is less dense than the surrounding air. So because it's less dense, it's buoyant.
Think of buoyant as being able to float. If you imagine a submarine in the ocean, it can either stay submerged underwater or float on top like a ship. Obviously, a submarine is very heavy, but it can float on top of the ocean when its ballast tanks are filled with air, making it less dense than the ocean water. If the tanks are only partially filled with air, then the sub can travel underwater at varying depths. If the tanks are completely filled with water, then the sub would sink to the ocean bottom. Air density and pressure affect the buoyancy of clouds in a similar way.
Pressure is related to the weight of the air above us. We actually have about a ton of air above you and a ton of air above me.
That's a lot of weight on my shoulders. I'm here with Justin Arnott, and we're here to talk about storms. You hear lots of different terms for big storms. I know hurricane, typhoon, tornado. What's the difference between each of these different storms?
Well, actually, hurricanes and typhoons are the same type of storm. It's just where they occur. If you're in the Atlantic or in the Pacific east of the international date line, you'll have a hurricane. But if you have that exact same storm west of the dateline of the Pacific Ocean, it'll actually be called a typhoon. So there's really no difference there. Now a tornado is different. It's something that happens over land, is much smaller, and forms from thunderstorms versus big, maritime storm like a hurricane is.
And how does statistics help you predict these different types of storms?
Statistics is one of the main things we use to help determine how well we forecast. We can actually go back after the fact and determine, well, how many times did it rain when we said it was going to, and how many times did it not. And that's one of my jobs here, is to go back and do research using statistics to help us learn from what we do, both the good and the bad, and to make our forecast better.
Just personally, I feel like a tornado seems like the scariest thing.
Tornadoes are, for a single point, are likely to cause the worst damage, but they're very small. A hurricane may not produce as much damage in any one spot, but it's a much larger area. And then a winter storm may impact millions of people with significant snow and ice. So it depends, for any one person, any of them could be their worst weather to deal with.
What a beautiful day. Look at all the fun shapes in the sky.
Oh yeah, those are cumulus clouds, and if you'll notice those are coming in from the northeast, and if those cumulus, see how bright they are? That's because there are a lot of little cloud droplets in them, and I'd say probably about a gram of water per every cubic meter in those clouds.
Okay, still looks like a bunny rabbit to me.